Well, hey, algebra students, and hope your Thursday's going all right here at this point in the afternoon. We're going to go ahead and get into Unit 8, Lesson 2, the video lesson here, and I'll try to keep it moving. Feel free to pause and rewind as needed. So we're going to start here by talking about slope. So slope is the way to measure a steepness, or the steepness of a line. So how steep is it? Just very gradual, or a very steep, very high line. We might write it here as m is equal to the rise over the run. Of course, the rise being the change in the vertical, always divided by or a fraction or a ratio over the change in the horizontal, which we call the run. And so some different types of slope. Typically, slopes are either positive or negative. So positive means the y, or the height, is increasing as the x is increasing. So the y goes up as the x increases, so they both increase together. Negative slope, on the other hand, would be a downhill line, whereas the x is increasing as we're going across to the right. Notice the height is actually going down. So as one is increasing, the other is decreasing. And so just kind of keeping those two in mind. Some special cases, we have a zero slope. If it's just a flat line, it means there is no slope or incline to it at all. So we call that a zero slope. And then a no slope or undefined would be like straight up and down, kind of like a telephone pole. You're not really able to measure how steep something is if it's straight up and down. It's like infinite slope, basically, like infinity, which we're just going to say is undefined or no slope. We really can't describe it. All right, so to find the slope from 2 points, we'll be doing quite a bit of this here today. You can start with any 2 points. We've got x1, y1, x2, y2. We just numbered. So the first ordered pair, right? Ordered pair number 1 has x1 and y1, and ordered pair number 2 has x2 and y2. And so the beauty here is we can do any 2 points because the slope is constant across the entire line. So any points you pick should work just fine. But here's what you're really going to want to know, and that's that the slope is calculated as y2 minus y1, hence the rise, over x2 minus x1, hence the run. So we're still doing rise over run, but this is the way we would do it given 2 ordered pairs. And so let's do that here with example 1. So notice we've got our first ordered pair, our second ordered pair. So the second y would be the 4, so we'll do 4 minus the first y is the 2, divided by the second x is the negative 3, minus the first x is the negative 1. Notice the minus and negative will become plus a positive on the bottom. So we'll get 4 over negative 2, which means we have a slope of negative 1. So the answer for first one would be negative 1. Let's look at example number 2. So here we're going to take the second y, negative 6, minus the first y, which is 2, divided by the second x, which is negative 5, minus the first x, which is 7. Negative 6 minus 4 is negative 6 minus 2 is negative 4. And then negative 5 minus 7 is negative 12. Notice if we can reduce, we definitely want to do that. So that would reduce down to 1/3. So our slope here would be a slope of 1/3. All right, example number 3. Use the slope formula to find the slope between those 2 points, and then sketch the graph to explain your answer. So let's start with doing 4 minus negative 2 over top of 5 minus 5, which would give us 6 over 0. Notice, if we've learned anything last couple chapters, it's that we can't divide by 0. So at this point, we have to say undefined, which is actually our situation where it's like there's no slope. Remember, it should be going straight up and down. It's one of our special cases. But let's go ahead and graph these points and see if that's actually happening. So 5, negative 2 be right about there, and 5, comma 4 would be up there, and if you notice what that line would look like, it would be straight up and down. Once again, we can't define that slope, so we would say it is undefined. Here's another situation here. We've got the second y, negative 2 minus the first y. That's actually going to be adding 2, and then we got negative 8 minus 3 for the second x minus the first x. We're going to get 0 over negative 11, which means our slope would end up, in this case, though, being 0. So that is one of our special cases, but it's fine to do 0 divided by something else. You just get 0. So let's go ahead and graph these, see if that matches up here. Looks like this one's way off the graph. We're just going to pretend like it's right over there at negative 5, even though it's actually at negative 8. But the idea there is that it just goes right across there, so -8, of course, would be somewhere eventually over there. But you have just a flat line, so it makes sense that the slope is 0. All right, so a couple last things here. So we're going to use slope to graph the line through a given point. So what we'll do here first is plot the given point, and then from that point, notice we're starting from that location, then you can apply or use the slope, or as I like to say in Math 8, you travel the slope, from that starting point. It's like kind of like if you're gonna, slope is like a rate of change. It's like, you get in a car or whatever, if you're gonna drive 50 miles an hour, well, you gotta get in the car first. It's located somewhere before you can just start driving off in it. So in this case here, we need a point or a starting location, and then you're able to travel, use that slope, use that rate of change to go somewhere, to then get, in this case here, to a second point. And then just kind of double check here. Of course, positive slope means it should be going uphill. Negative means it should be going downhill. And so we're going to kind of see what that looks like as we graph it. And we'll, of course, double check at the end that it actually, makes our slope makes sense with what the graph looks like. All right, so let's start with our given point. -3, 2 starts right about there. And then a slope of -1. Notice instead of rising, if we're rising a negative number, we're actually falling. So we're going to say that we're going to fall 1 here. So that goes down 1 to there. And then I always like to say the number on the bottom, though, is always going to the right. So you can kind of use the sign on the top, of course, to decide are you going up or down. But what's nice is then on that bottom, the number on the bottom, you can always go to the right. So here we're going to go ahead and go 4 then, 1, 2, 3, 4 to the right. So that's where that second point should end up at. And I'm going to try and draw a line through those two. There we go. That's not too bad. All right, so we get that line there that goes through that. Now let's double check. Up here it looks like we should have had a negative slope, and sure enough our line is going downhill. So just to double check, that looks like everything checks out there. All right, example 6, same kind of deal. Let's start at 4, 3. And then a slope here of 2. Remember, an integer can always be written over 1. So basically that means 2 up and 1 to the right. So we're going to go 2 up and 1 to the right. And that should go something like that. And then just double checking, positive slope, positive uphill line. We're good to go there. All right, I believe this is the last example here. So say we get something like this that's written in standard form. It's not written in slope-intercept form. We could either rearrange it and solve for y, so we could try and rearrange it to get, y equals mx plus b form, and then you can graph it. Now, we're actually going to be talking about that a little bit more with tomorrow's lesson, so that actually might make a little more sense tomorrow. But today we're going to do something a little simpler. We're just going to find the x and y intercepts, and we're going to use those to graph the line. In fact, in this case, also to figure out what the slope here probably will be when we're done. But let's find those x and y intercepts. So remember the y-intercept, if you think about that, that's where it hits this y-axis. If you think about what's the x value is right here in the middle at 0. And so that means we're plugging in x is 0 to find the y-intercept. Okay, now when x is 0, that means anything times 0 drops out. So this 4x is going to drop out there. And we call this the cover-up method. It's because we covered up the 4x, and we're basically going to solve the rest of the equation. And once again, it's because the x dropped out. So at that point here, we can divide both sides by -5, and we'll get y here is equal to 4. So let's put that up here at 4. So that would be the y-intercept. And now to find the x-intercept, we're going to swap it here. And we're going to say that y is equal to 0, which means you cross off the y-coordinate. We're going to be left here with 4x is equal to -20, which if you divide both sides by 4, x here would be equal to -5. So let's put -5 on there. So now we have our x-intercept and our y-intercept. And if we want to find the slope of the line, I guess first of all, let me draw the line there in. So it looks something like that. But if I want to find the slope, we want to find, well, what is the rise over the run? So let's count. We go up 1, 2, 3, 4. So we're going up 4. And then we're going to the right 1, 2, 3, 4, 5. over 5. So we would say we have a slope here of 4 over 5. So that would be our slope on this one. And that concludes our video lesson here.